there is no session next week, and the reason is that we moved the group because of various problems up to the end of the course instead. So that's how the way it looks right now. If I find anything, I might throw something out where you can get an extra attendance or something, but I can't promise that. I had something in mind, but that didn't work out, so that's why I'm a little bit tentative to come out with it. But in that case, I will inform about it at the latest tomorrow. All right, but that will be above the normal scheduled ones. So, okay. All right, so we'll just get going with today's lecture. So please.
All of us here know that we are conscious. But what is consciousness? Can we define it? Can we prove that we are conscious? And if we cannot, how do we decide if someone else or if something else is or is not conscious? With these questions, we welcome you to this talk about consciousness and integrated information theory. And this is a brief summary of the topics we'll be touching today. Initially, we will look at the history of the concept of consciousness, followed by a closer look at the question of who is conscious and see where that leaves us. Then we will look into consciousness and neuroscience, and last but certainly not least, we will jump headfirst into integrated information theory, or IIT for short. So history then. Historically speaking, we've always theorized about our consciousness, but the way that we look at consciousness today is often attributed to the philosopher John Locke. In 1690, he defined consciousness in his essay concerning human understanding as the perception of what passes in a man's own mind. And if we were to compare that to a modern dictionary, which defines consciousness as awareness or perception of an inward psychological or spiritual fact, intuitively perceived knowledge of something in one's inner self, we see that the concept is still very much the same. However, there has been some criticism towards these definitions. There are philosophers claiming that this is self-consciousness as opposed to more general consciousness, that would be more like pure sensation or awareness of outward condition. This is still how most of us look at consciousness. And with this common framework, we can look at the question of who is conscious in more detail. So let's start with this from my perspective. Let's make a list of things that I think are conscious. And a good place to start would be to mention another famous philosopher that has contributed to the subject. René Descartes famously expressed the words cogito ergo sum, I think, therefore I am. So, unless it's far too early in the morning, I can start by adding myself on this list of conscious things. And then when I'm standing here, I realize that I'm in a room full of people that are not extremely different from myself. So maybe it's not too far-fetched to add you to this list as well. And we're humans as well. Homo sapiens sapiens. We're an animal. And there are other animals in the world that also exhibit somewhat conscious-like behavior. So maybe we can add them to this list as well. And at first glance, it seems like this list is done. Maybe. Or can we expand it? Could we add other living things like plants? Is this potato conscious? I mean, it looks happy. Could we add computers as well? Could we construct a conscious computer like HAL 9000 from the film 2001? And these last two questions about plants and computers are not new to our time. In fact, panpsychism and artifact consciousness. Panpsychism is one of the oldest philosophical views that exist, and that is the view that consciousness is a universal feature for all things, meaning everything is conscious in a way. And artifact consciousness, inanimate objects with consciousness, is an ancient theme in mythology. For example, the Greek myth of Pygmalion, where a statue comes to life. With this background, however, we have in later times started to ask the specific question, can machines think? But the more we look at that question, the more we can start to question the question itself. What do we mean by think? And what exactly do we mean by machine as well? Are we not chemical machines, in a way? So in conclusion, it's a kind of bad question. Let's change it. Let's go. Instead, let's play a game. Let's play a game called the imitation game. Some of you might know where I'm going with this. It's an old game consisting of 3 players. Player A, B, and C, where player A is a man, B a woman, and C can be either or. The goal of player C is to make the correct guess of which player is which through only conversing with the other players in some anonymous way, like writing notes on a piece of paper. And player A is then supposed to trick player C into making the wrong guess, and B is supposed to help. So let's, yeah, that's what I just said. Let's construct a new game where player A is a machine and B and C are both humans. Both A and B are supposed to convince C that they are the human in the test, or the game. And if player A, the machine, manages to do so, it wins, or passes the test, if you will. Because most of you here probably recognize this as the Turing test. It was Alan Turing who first suggested that we remove the question from earlier and exchange it with this game. This game does, however, avoid some or even most of the philosophical questions concerning consciousness. And there has been criticism towards it as well. One of the most famous criticisms is the Chinese room argument. It's a thought experiment formulated by John Searle in the 1980s. And the point of it is to differentiate between understanding and simulated understanding, or strong versus weak AI, as Searle himself expressed it. And it goes as follows. A non-Chinese speaker is in a closed room with a book of rules of how to take Chinese signs as input and then generate an output. And then the person has pen and paper to write these messages down and send them out of the room. If this book of rules is good enough, such a person would be able to take Chinese signs as input, generate output, and send them out to such a degree that a Chinese speaker sending these messages might mistake them for another Chinese speaker. Of course, the person inside the room still don't understand Chinese, which is the point of this whole thought experiment. If the test would instead be taken in a language the person does understand, the book would not be needed and the test would still be passed. These things I've talked about is a brief summary or some basics of consciousness, mostly from a philosophical or everyday perspective. And now Joel will move on to the subject of consciousness and neuroscience, as well as look at the one of the philosophical problems that the Turing test avoids.
Alright, so neuroscience is basically the study of the brain and how different neurons interact with each other. And modern neuroscience started to shed some light on what consciousness is. And this is done by studying connections in the brain with the alternating states of consciousness. How the connections in the brain changes as the state of consciousness changes. So then we need some different, what are some different states of consciousness? So they can be introduced, for example, by meditation, where the practitioner sits down and tries to still their mind. Another way is to use a psychedelic substance, where it's a chemical that affects how the brain works. And the third way is dream states, where the consciousness is also very not as it is when you're in your awakened state. Two of these, meditation and dream states, are really hard to replicate on a manner that you can, now you want to test it and now you don't test it. So we have an advantage with the psychedelic substances, because you can give subjects this substance, and you can also give subjects placebos, so you can measure the real effect. So in one study, they came up with this picture. So all the dots here are small networks in the brain, and the lines between them are connections between these different networks. In the left, we see the networks of a brain that's on placebos, and to the right, a brain on psilocybin, which is a psychedelic substance. And as you see, the brain to the right has way more connections. And this could explain the radical alteration of consciousness that psychedelics introduce. And it could also explain one common experience of synesthesia, which is hearing colors or smelling sounds, for example. And different networks are connected in a way that they're not used to. But there's a problem with only studying the physical aspects of the brain to understand consciousness, and that's the mind-body problem. Here in the Western world, we often see the mind and the body, or the soul and the world, as different entities. So in science, we have this view of the mind as interacting with the physical world and deciding what to do in it. And in Abrahamic religions, Christianity for example, we have the example of the soul going to heaven or hell when the physical body dies. But it's different in the Eastern world, where as in Hinduism and Buddhism, they see the mind and body as more of one thing, and the dualism that we experience between the mind and the body is only two different aspects of the same thing. And we also see that these kind of ideas are starting to creep into the Western world in practitioners like mindfulness, which is basically meditation practice or packaged for Westerners. So with this in mind, it seems like we need a more holistic approach to describing consciousness. And Julia will now go through the integrated information theory, and that tries to address some of these issues.
So consciousness is clearly hard to define, but in recent years, theory, which is intended to explain and understand consciousness in mathematical terms, has gained traction. And it's called integrated information theory. And what this theory does is that it gives a system a level of consciousness. However, this theory is still not fully developed, and at the same time, this theory is also very complicated, so we're only gonna scrape the surface of this today, but hopefully you will get a better conceptual understanding, at least, of what it's all about. So, usually when models are created, you start out with looking at the characteristics of a system and try to define what might be the underlying mechanisms. But when it comes to integrated information theory, the opposite approach was used, and people working on this started out by defining 5 axioms that they thought were self-evident truths about consciousness. And out of those, they constructed 5 corresponding postulates, which can be seen as realizations of the axioms. So what should the model actually look like? And by doing so, they came up with the integrated information theory. So the axioms they all agreed on was existence. Consciousness exists. I think, therefore I am. And I mean, if we don't agree on this one, we don't even have to bother about coming up with a model. So it's pretty self-explanatory. Composition. Each experience consists of multiple aspects and various combinations. So within the same experience, you can see colors, you can hear sounds, smell stuff, feel the temperature, and so on. But you can't just decide to eliminate one of these things. Therefore, all those things are part of the experience. And then there's information. Each experience differs in its particular way from other possible experiences. So no experience is exactly the same as any other experience. Then there's integration. Each experience is strongly irreducible, which means that a blue heart, for example, is not the same thing as the combined experience of the color blue and a heart. And lastly, exclusion. Each experience excludes all other experiences. So if not, that part should also be part of the experience. So at any given time, only one experience is having its full content, rather than being a superposition of multiple partial experiences. So all these axioms have corresponding postulates, which should be fulfilled in order for the model to work and to be a model of the physical substrate, which might build up the consciousness. But instead of going further down in the theoretical parts, we're going to look at a very simple example of a conscious system. So what we have here is a minimally conscious system, and it works like this. A and B are neuron-like logic gates, and then we have these connections, which could take values either 0 or 1. And if A's input signals sums up to more than 2, it turns on and outputs a 1. And if B's input signal is 1, it outputs 2 ones. And we're going to think about the system as being sensitive to light. So for each light bulb we turn on, we have an input signal being on, being a 1. So what happens if we turn on one light bulb? We get a 1, but that's not enough. So A doesn't turn on and nothing happens. But if we turn on both light bulbs, A turns on, which makes B turns on, and the system experiences light. And the way the system works is that B functions as a memory. So next time we try to turn on 2 light bulbs, 1 light bulb, I mean, A turns on, B turns on, and we experience light again. So the system has changed a bit from the previous experience. And so why is the system conscious? It's conscious because A says something about B's future, and B says something about A's future. And well, in more general terms, past experiences affect future experiences. But as I said, this is a minimally conscious system. So what can make a system more conscious? That brings us to integrated information, which is information that is generated by a mechanism above and beyond the information generated by its minimal parts. So the combined information is more than the sum of its individual parts. And a simple way to explain this is 1 + 1 = 3, and not 2. And the way consciousness works, according to IIT, the theory, is that only mechanisms that give rise to integrated information contribute to consciousness. And integrated information is denoted with phi. But in order to actually calculate phi, you have to do some rigorous calculations, and for like the brain of humans, it's not even practically possible. So what we're going to do instead is to look at two systems, and one of them have a bit more integrated information than the other. So this is the system. We have A, B, and C. A turns on if the input signals, we have an even number of input signals being 1. B turns on if the majority of the input signals are equal 1. And C turns on if A and B are 1. So let's say we have an output signal which is on. Then A and B were on as well. And then the two input signals might have been on all of them, or it's also possible that the two upper ones were off. But now let's compare this to a simpler system with some additional connections from the input signals to A and B. Now, if we have an output signal being on, we know that A and B were on as well. But because the majority of the input signals were on for B, we know that the input signals could be either 3 ones or 4 ones. But at the same time, A only turns on if we have an even number of input signals being equal to 1. So it has to be 4 input signals being equal to 1. So this is an example of a system which has, when you combine the upper and the lower part, you gain even more information and you gain integrated information. So this system has a higher phi than the previous one. And now Joel will continue to talk about IoT, talk about the implications and limitations.
Alright, so IoT seems like a really cool theory, but what does it imply and what can we get out of it? So first, we have a framework for thinking about consciousness and for measuring consciousness. And maybe this could be used in various applications like deciding what to do in moral dilemmas. Maybe we should optimize or maximize the level of consciousness in a system. Another thing is that the consciousness is universal, which means that our cats and dogs are universal, are conscious. That's all we want to know, right? But IoT goes way beyond that. And we might have to fundamentally rethink how we relate to consciousness and our model of it. So, for example, think of a really complex molecular structure. It's not that hard to imagine that it would get some value for phi. And if we go even further down, if we think about a proton that has 3 quarks, that should also maybe have a non-negative value of phi. In that way, maybe IoT tells us that everything is conscious, and even if only a tiny amount. So maybe it's kind of like a modern version of panpsychism mentioned earlier. We can also explore some cool ideas. So if we look at the larger scale and think about the internet, it's a large network with a lot of different nodes, and at each node we see a human providing input, or that could be sensory information to the large internet brain, and that would be where information would be integrated. So maybe we can think of the internet as being conscious. Another cool idea is that a computer usually provides us with a lot of information, but the computer itself probably has a low value of phi. But as a human, that is conscious. We have like a large value for phi, and we have we're good at integrating information into our experience. So when I sit by a computer and gain access to a lot of information, maybe I become more conscious. Yeah. So what are the limitations of IIT? Well, firstly, it's really hard to calculate. If we imagine the human brain, or even the brain of a quite small animal, the brain would be really complex, and it's almost impossible to take a snapshot of the brain and then create a model of that exact brain. And even if you could do that, the calculations needed for the IIT to measure the phi in IIT would probably be really computationally expensive. Another thing is that, like Julia mentioned earlier, that we begin with axioms and then create a mathematical model of what we think consciousness is. And this is not really how science usually works, where we look at the world and create a model of the world from the observation. So maybe this cannot really be tested in a more regular scientific way. We also have like more fundamental problems, like why does consciousness exist? IIT doesn't really bother with this at all, and like how did consciousness get here in the first place? Like before we were humans and we had life, how did it get here? Yeah. So that are some of the limitations. So thanks for listening, and now I would like to hand over to Klaus for his yeah.
Short remarks. Thanks a lot. Okay, thanks. This IIT, I hadn't. Well, I've seen it, but I haven't read about it. I don't know how old is it? For how long have they been working on this?
I guess like